checking if I have any more of those note packages or if I've handed them all out. If you've lost it, then go. We are on page 19, right? And we had done examples of all of the other power rules from grade 9.
Should be on our next quiz.
Yes. So we're going to finish today. We're going to set up another quiz, which is when? Tomorrow. Page 9 to the end. We have our quiz. So we have to finish up our booklet today.
I guess I missed.
You might want to catch up on those videos if you've missed the first part. Now, what we did here is we checked, first of all, we did an example with numbers. If you had 2/3 to the 5, according to this rule, this means you have 2 to the 5 and 3 to the 5. If we think about what an exponent of 5 means, that would be 2/3 multiplied by itself 5 times. Does it make sense when you multiply fractions, you multiply the tops, you multiply the bottom? So if we look at regular numbers, we can see why it is that the rule says what it says. And the reason we have to look at numbers to understand it is because if you went to variables, this would be x cubed over y cubed. But if we went to fractions, if I had x squared over y to the 8 to the 1/3, all of a sudden we can't visualize it like we used to. So then we need to know the rules. So our exponent rule makes sense when we think about numbers. It makes sense when the numbers are whole, even with variables, because this would be x over y times x over y times x over y 3 times, because that's what an exponent of 3 means. And then you would have x cubed on top, y cubed on the bottom. But the reason we need to know the rule that the exponent goes to each thing is because as soon as you get to fractions, we can't visualize it anymore. So now, if I want to do the purple one, I have to know that the 1/3 is going to go to the x squared, which will give me x to the 2/3. Because an exponent to an exponent, this is 2 over 1, we would multiply. And the 1/3 goes to the y to the 8, which is 8 over 1. 8 over 1 times 1/3 will be 8/3. And in order to do the purple one, I need to know the rule and how it works. In order to do the green and the black ones, I can just think about what an exponent means and figure it out. But that doesn't help me when I get to the purple one. So the rules are there so that when we get to more complicated ones, we can still do them. But we have to remember, or we can use our knowledge of what an exponent means to help us remember what the rules are. So if you forget a rule, go back to nice numbers, nice whole numbers, and think about what it means, and you'll figure out the rule, and then you'll be able to do it. So today, we are working on our rules. Okay? So you've got 4 questions there to start with. I'll give you a couple-minute head start. Try them on your own. Check with a partner. If you get stuck, ask questions. And then I'll put those answers up, and we can see how we're doing. No calculation. So all you do in this one, write as a single power into the question, so that means you don't have to simplify it. We get 0.6, add the exponent would be -5. which is the same as 1 over 0.6 to the positive 5. But as a single power, this would be fine as a final answer. So multiplying with the same base, we have to add the exponent.
Wait, why'd you put 1 on top?
Because this is your negative exponent rule. It's another rule that we learned this year. So I'm just reminding you that anytime you have a negative exponent, you can switch it to the other side of the fraction. Did you win your game? Yeah.
Yeah. I scored a 5th goal for our team, and then they called it back after.
Oh.
Unintentional goalie contact. A new rule they added.
Okay. So, second one. Power to a power. That's an exponent law where we multiply. So that would be negative 2 sevenths to the negative 12. Here we have another power to the power. We can multiply. Now we're dividing. I could write it like this, or I could have written this I could have also written this like this. Do we have a rule for dividing when we have the same base? Yes. What's the rule for dividing when you have the same base? Subtract the exponent. So, if I did that, what is negative 12 minus negative 10? Negative 2. Okay?
Why are you subtracting?
Why are you subtracting?
Or adding? Yeah,
These are your grade 9 exponent rules. This is exponent rule number 2, quotient. If you're dividing two powers with the same base, you can subtract the exponent. Oh, yours is, oh yeah, that's good. Then, you have the exponent to a fraction rule. This would be negative 2 to the negative 2 and 7 to the negative 2. The exponent would go to both of them. Which is equal to, the negative exponent rule means I can move the 7 to the top and the negative 2 to the bottom with my negative exponent rule. And if I wanted to evaluate this one, like technically, the way the question is written, this could be a final answer because it says right is a single power, this is a single power. But if I wanted to simplify this one, 7 squared is 49, negative 2 times negative 2 is positive 4. This would be the simplified answer. So we notice that our simple rules from grade 9, we add all the fractions and a couple new rules. They get complicated. Okay? Technically, this is a single power because we have one thing to one exponent. That would be a final answer. But just showing that we could simplify this one further and knowing the rules about how that works. Third one. 2.7 cubed to the negative 5. We have a power to a power. We can multiply those and get 2.7 to the negative 15. Then, we're dividing. Can you see that we have the same basis? So we can subtract negative 15 minus 4, negative 19. Now technically, you could leave your answer like this because this question said write as a single power, and we have a single power now. But because it's negative, you could also change this to 1 over 2.7 to the positive 19. on the top of this fraction, do you see that you have powers with the same base? So what's the rule when you're multiplying two powers with the same base? You add the exponents. So on the top, if I add my exponents, can you see that you would get 9 to the, I mean, we can show the work. That's me adding my exponents.
That was 5.
Yeah.
That is a 5.
That was.
That would be a 4.
And then, negative 1 over 4 plus 5 over 4 gives me 4 over 4, which is just 1. And now what is, well, I'm going to keep it at 4 over 4. Is that okay if I keep it at 4 over 4? It's kind of nice because what's our next exponent rule? We have to subtract. So subtracting fractions, you need a common denominator anyways. So if I keep it at 4 over 4, and I subtract, I get 9 to the 1 over 4. And there's so much mental math that you guys can do with these that you should be practicing. Okay, so we're doing fraction stuff here. Like playing around with 9 to the quarter. See, here's a challenge question for you. Can you prove to me that 9 to the 1 quarter is equal to 3 to the 1 half? Why are those the same? Why is the 4th root of 9 the same as the square root of 3? And these are the mental math things that if you play around with, you will remember your rules and you'll figure them out. Okay? I'm going to just leave that. You see if you can figure out why they're the same. But we want to make sure that we finish everything so that you've got your notes ready to study for tomorrow. So again, I'll give you a little bit of time to start working ahead. What are we doing? We're multiplying. If you have the same base and you're multiplying, you can add the exponents. This one's really easy to visualize because I have A, and then A. How many A's all multiplied together?
Do I get the laws on tests and quizzes? Can I?
You'd have to look on your formula sheet.
Are they?
Are the laws on your formula sheet?
I don't think they are.
Probably not, because they're from grade 9. So since you learned them in grade 9, you now have to know them in grade 10. So you would have 8 A's, and b to the 7, we're multiplying, so I add my exponent. 7 plus negative 3 would be b to the 4. You did it?
I did it.
Nice.
Yeah. Yeah, that's the only one I got. I gave up on others.
A fraction. What's the rule for fractions?
Yes.
Subtract the exponents. First of all, the numbers, can you do anything with 8 over 12? You could reduce it to
So then you mentioned 4.
2 over 3.
2. That's a 2.
And then if I subtracted exponents, x to the 8 and x to the 5, I would be left with x to the 3. And with y to the 3 minus, we have y to the 3 on top, y to the 7 on the bottom. If you subtracted, you would get y to the minus 4.
Why'd you put it on top?
Because I used the exponent law for subtracting. Now, with a y to the minus 4, I could write that on the bottom with a positive 4. And some people will go directly from here to here because they'll say, if I cancel things out, I have 8 x's on the top, I have 5 x's on the bottom. 5 of them are going to cancel out, and I would be left with 3 of them on the top. If I canceled out from my y values, I'd have 7 y's all multiplied on the bottom, 3 y's on the top. Can you visualize this? Is it helpful? How about if I do this? Here, watch what's happening in this one. We had the 8, we had the 12, we have 1, 2, 3. you see that when they cancel out, you're left with 3. I canceled out too many. Oh my goodness. Count 1, 2, 3, 4, 5 of them cancel out. You're left with 3 x's on the top. And when you cancel out your y's, 1, 2, 3, 1, 2, 3, you'd be left with 4 y's on the bottom.
Oh, I see what you're doing. No, wait. Oh, yeah.
So some people thinking that way would go directly to this answer. But some people would use their laws and say dividing means subtracting. And if you use the law, you would have 3 minus 7, which gives you y to the negative 4.
So
But then your negative exponent rule tells you should put that on the bottom of your fraction.
So that's right, just harder and longer. Or is it wrong?
No,
That's
they're both right.
Yeah, it's just hard.
Which, this is easier to visualize, right?
Yeah,
Okay.
on the test,
But you would
some
need
do
to
that.
use this. You can only visualize if the numbers are nice whole numbers.
Yes.
If I switch to fractions, then you'd be forced to use your laws all the way through.
Okay.
Okay, so you do need to know both. Here's a fraction. Here's one that you couldn't write out.
Okay.
Okay, so I would have 25 to the 3 halves, a to the 4 to the 3 halves, b squared to the 3 halves.
Oh, yeah.
So I would need to multiply the 3 halves into the exponents of each one. Can you do the mental math and tell me what number should go in there for 25? And this will be a to the 6, because 4 over 1 times 3 over 2 would give me 12 over 2, reduces to 6. And this one would reduce to
3.
b cubed. Now, I'm going to put 125 in here. How do we do that mental math to figure that out? 25 to the 3 halves is the same as 25 to the half cubed. What does the half do?
5.
The half would make it a square root, right? And square root of 25 would be 5. So then you would get 5 cubed, and 5 times 5 times 5 gives you 125. We good? Yep. Okay. So we have to be able to recognize what laws are present. Do we have here, this is just multiplying, so this technically is the same as this. We just have 4 things multiplied together. What is our rule for multiplying? Well, if you're multiplying and you have the same base, you can add the exponents. Can you see that these two have the same base? If you added the exponents, you would get x squared. Can you see that these two have the same base?
Yeah.
If you add the exponents, negative 3 over 2 plus 1 over 2 would be negative 2 over 2, which would give you negative 1. Negative exponent rule would put the y on the bottom of our fraction to a positive exponent of 1. And then you wouldn't have to write that positive exponent of 1. But I did it just to show you how that switched. So usually we say something is simplified if there are no negative exponents. So even though these two are final answers, this one would be considered the best answer because it has no negative exponents in the end.
Would it be y1? Can we just keep it as y?
I would just keep it as y. But I just showed when you move it down, the exponent becomes positive. So just to really show that, I added the 1 there. But you don't need to write an exponent on 1.
Wait for the next, this one, do 3 and 12.
Well, we can do the numbers and the fractions. Could you simplify 12 over 3?
Yeah.
What would that be?
4.
4. So we would be left with a 4 on the top. Okay? Here, you have to use your exponent laws because we've got fractions.
Mm-hmm.
What is your exponent laws here? These have the same base. What's your exponent law for dividing? Subtract the exponents. So I would get, if I subtracted, I'd have to negative 5 minus a half. But we're subtracting fractions. Are you okay if I change the negative 5 to negative 10 over 2? And I subtract 1 over 2. What about the y's? They also, these two also have the same base. So I could subtract those fractions, 5 over 2 minus a negative 1 over 2. Is there anything left on the bottom of my fraction? No, but I'm going to put a 1 there just because I drew the line. You wouldn't have to write anything there, but there's nothing left on the bottom. So what do we get here? We still have the 4. What is negative 10 over 2 minus 1 over 2? Negative 11 over 2. And what is 5 over 2 minus negative 1 over 2? Now it would be y to the 6 over 2. 6 over 2 simplifies to just 3. Our final simplified answer, since we have a negative exponent, I would move that to the bottom. And we get 4y cubed over x to the 11 over 2.
Can you go back for a second?
I can.
Thank you.
So generally, technically, we are, the only thing new that's grade 10 in this question was the negative exponent rule. Although some of you might have saw that in grade 9, depending on your teacher.
Didn't you do that?
I probably showed you the negative exponent rule in grade 9. Okay? Which means this is a complete review question. What makes it hard is you have to know really well 2 things from previous years. You have to know your exponent rules really well, and you have to know fractions really well. And this shows that everything in math that we do will take from previous years. So if you didn't learn it well in grade 9, because you're like, I don't remember these rules, that means now in grade 10, you have to spend extra time to go, how do I learn this well enough? So when this comes up again in grade 11, by then I'm like, okay, I know how to work with fractions. I know how to work with my exponent laws. Okay. And with your exponent laws, you have some options, because you can decide to do whichever exponent law you want to do first. Okay? In this situation, I would probably simplify in the brackets first. That's sort of order of operations, right? If you can simplify in the brackets, you'd want to do that. Can you see that 50 over 2 I'm going to simplify in the brackets first. What is 50 over 2? 25. Can I simplify my x to the 4 and x squared? Okay. This might be one that some people go right away and put the x squared on the bottom. Can you see that there's 2 more x's on the bottom than there are on top? If you did your exponent law, you would get x to the minus 2. But then you would have that on top. And for the y's, can you see that there are 3 more y's on the bottom? So if you did this right away, that's perfectly fine. If you used your exponent law, you would get y to the negative 3, which would have to move to the bottom anyways. Now what does the half do? The half goes to everything. 25 to the 1/2, x squared times 1/2, y cubed times 1/2. Well, what is 25 to the half? That's 5, because it's the square root of 25. And x squared times 1/2, this is 2 over 1. How do you multiply fractions? Multiply the tops, multiply the bottoms, 2 over 2, which is just going to be x to the 1. Again, 3 is 3 over 1. How do you multiply fractions? Multiply the tops. Did someone say easy?
I said nothing. I said nothing.
You think they're easy yet?
It's becoming more easy.
It's becoming more easy. That's a better way of saying it, right? Because if someone says they're easy and they're still hard for you, you just kind of like, you shouldn't punch them, but you kind of feel like punching them, right?
I'll get it wrong on the test and I'll look back at it and I'll be like,
And pull out.
Or scissors.
No.
do you want your cookie?
That was easy.
No, not that button. I don't like that button.
And there is your homework list. I've also, if you really want to practice these, I gave you a handout as well with a lot of these fractional ones on there. Those would be good practice. So we're going to end here. You're going to get your first